Assalamu alaikum. Today we are discussing the topic catalysis. It is a topic of surface chemistry, semester 6. Before proceeding towards the term catalysis, we would like to introduce some terms like catalyst, promoters, inhibitors, and poisons. What is catalyst? A catalyst may be defined as a substance which speeds up the rate of a chemical reaction and is obtained at the end in the same chemical nature, same structure, same amount. However, its physical state may get changed. Catalyst is a substance which speeds up a chemical reaction and is obtained at the end in the same chemical nature, same composition, same structure. However, its physical state may change. Physical state or shape may change. For example, oxygen is obtained by the decomposition of potassium chloride. Solid potassium chloride is heated and it produces potassium chloride and oxygen gas. In this case, manganese dioxide is used as catalyst, which is a solid. Now at the start, it is a compact solid, but at the end, we get a porous substance. It changes into porous state. So a catalyst may change its physical state from compact to porous or porous to compact, from crystalline to powdered state. Now catalyst has some characteristic properties. Characteristics of catalysts are: number one, catalysts are used in small amounts, in small quantities. Second, catalysts are specific in action. Catalysts can catalyze a specific reaction, and some other catalyst may be required for other reaction. And number three, a catalyst does not initiate a chemical reaction. They just speed up the reaction. And fourth, catalysts are recovered at the end of reaction. The unit for catalyst activity according to SI system is called Cal, denoted by Cat, and Cat is equal to 1 Cat means 1 mole per second. 1 Cat is the amount of catalyst which is required to convert 1 mole of reactant into products in 1 second. The quantity of catalyst, the amount of catalyst which is required to convert 1 mole of the reactants into products per second. Now, if we are dealing with biochemical catalysts, the biochemical catalysts are those substances which speed up the rate of a biochemical reaction then these biochemical catalysts are known as enzymes, like diastase, lipase, protease. And for these enzymes, the unit of activity, enzyme activity, is called enzyme unit. Enzyme unit is denoted by U, and one enzyme unit is equal to 1 micromole per minute, which means enzyme unit is the amount of quantity of enzyme which is required to convert 1 micromole of a substrate into product in 1 minute. Now there are some other terms which are generally used. First one is called the promoter. What are promoters? Promoters are the chemical substances which increase the activity of catalyst. Promoters are the substances which enhance the activity of catalyst. For example, in Haber process for ammonia, nitrogen gas reacts with hydrogen gas and we get ammonia. In this reaction, iron is used as catalyst. In addition to iron, molybdenum is also used. Molybdenum is a promoter which speeds up the activity, which increases the activity of catalyst. On the contrary, inhibitors are those substances which decrease the activity of catalyst and they work in reversible manner. If we remove the inhibitor, the activity of catalyst will be restored. For example, in the reaction between methane and chlorine to produce alkyl halides, different chlorinated products which are called alkyl halides. This reaction occurs in the presence of sunlight. It is a photochemical reaction, and alkyl peroxides, if they are used during the reaction, then they will slow down the rate of chlorination of methane. They will decrease the reaction rate and they act as inhibitors. If we remove the alkyl peroxides, then the activity of catalyst, the reaction rate will be restored. Next example is that of poisons. Poisons are the chemicals which decrease the reactivity of catalyst in irreversible fashion. It means that if the activity of catalyst is decreased by using poisons, we cannot restore the activity. It will be permanently poisoned. For example, alkynes can be hydrogenated in the presence of palladium catalyst to produce, in the first step, produce alkenes, and then the further hydrogenation will lead to the final product, which is alkane. However, if the palladium catalyst is poisoned with barium sulfate and quinoline, it is partially poisoned with barium sulfate and quinoline, which act as poisons, then we will only get alkenes and the reaction will not proceed to the final step, that is alkanes. Thus, in this case, barium sulfate and quinoline, They are acting as poisons for the catalyst, and they are decreasing the activity of catalyst. Now the question is, how catalysts increase the reactivity of substances? How catalysts increase the rate of reaction? The answer is that these catalysts, they decrease the activation energy of the reactants, and transition state or transition intermediate is obtained sooner. Activation energy is the minimum amount of energy which the reactants must possess in order to enter into chemical reaction. Less energy will be required for the reactants to enter into chemical reaction in the presence of catalyst, but more energy will be needed. They will require a higher energy to react in the absence of catalyst. So catalysts increase the rate of reaction by decreasing the activation energy of the reactants. Let us suppose if the reactants are activated at energy of 10 joule in the absence of catalyst, then they will be activated with an energy of 6 or 7 joules in the presence of catalyst. So catalyzed reactions are usually faster than uncatalyzed reactions. Now we come to the original topic, which is catalysis. What is meant by catalysis? It is a process by which the rate of a chemical reaction is increased, the rate of a chemical reaction is enhanced or increased by the use of catalyst. Now, catalysis may be of 4 types. There are 4 types of catalysis. Number 1, homogeneous catalysis. Second, heterogeneous catalysis. Third, enzyme catalysis. And there is also a 4th type, which is known as autocatalysis. We discuss them one by one. The first type of catalysis is known as homogeneous catalysis. Homogeneous catalysis may be defined as a process in which the catalyst exists in the same physical state as the reactants. If the reactants are gases and catalyst is gas and reaction is taking place, then this process will be called homogeneous catalysis. If the reactants are solids, the catalyst will be a solid, and if the reactants are liquid, then the catalyst may be liquid for homogeneous catalysis. So in homogeneous catalysis, the reactants and catalyst exist in one physical state. A process in which reactants and catalyst exist in one physical state of matter is known as homogeneous catalysis. Solid reactants, solid catalyst; liquid reactants, liquid catalyst; and gaseous reactants, gaseous catalyst. Examples of homogeneous catalysis are: first example, solid reactant and solid catalyst is the decomposition of potassium chlorate in the presence of manganese dioxide as catalyst. Manganese dioxide, MnO2, as catalyst. In this case, the reaction is 2KClO3 solid, MnO2 solid catalyst, heat, and we get 2KCl solid plus 3O2 gas. The physical state of products is not counted in this case. Only we consider the reactants and the catalyst. If the reactant is solid and the catalyst is solid, products may be liquid or gas, doesn't matter. If the reactant is solid and catalyst is solid, it will be homogeneous catalysis. Second example is The nitration of benzene C6H6 benzene is in liquid state. The second reactant is nitric acid, HNO3 concentrated. It is also in liquid state, and the catalyst is concentrated sulfuric acid, which is also in liquid phase. The mixture of concentrated nitric acid and sulfuric acid is called nitrating mixture. So the reactants in this case are benzene and nitric acid, which are liquid. The catalyst is concentrated sulfuric acid, which is also in liquid state, and we get nitrobenzene C6H5NO2 liquid plus water liquid. In this case, both the reactants benzene and nitric acid are in liquid state, and the catalyst, which is sulfuric acid, is also in a liquid state. Similar is the case with sulfonation, in which benzene, which is a liquid, is treated with concentrated sulfuric acid at 100 degrees centigrade to produce benzene sulfonic acid. Now in this case, sulfuric acid act as a catalyst as well as act as reactant. Now benzene and sulfuric acid are reactants which are liquid, and H2SO4 also act as catalyst, and it is also in liquid state. The third example of homogeneous catalysis is the lead chamber process for sulfuric acid, in which the reactants are gases and the catalyst is also a gas. Lead chamber process for sulfuric acid. In the lead chamber process for the manufacture of sulfuric acid, the main reaction is the reversible oxidation of sulfur dioxide to sulfur trioxide in the presence of catalysts, which are oxides of nitrogen, NO gas plus NO2 gas. The reactants are gases and the catalyst is also a gas. So in homogeneous catalysis, the reactants and the catalyst exist in one physical state. Examples are the decomposition of potassium chloride to produce oxygen. This reaction takes place in the presence of manganese dioxide, which is solid. Reactant is solid and catalyst is solid. Second example is that of a reaction between two liquid reactants in which a liquid catalyst is used. For example, the nitration of benzene. Benzene is liquid, nitric acid is liquid, and the catalyst sulfuric acid is also a liquid. The products formed are nitrobenzene and water. Same is the case with sulfonation, in which benzene is treated with sulfuric acid in the presence of sulfuric acid as catalyst to produce benzene sulfonic acid. The third example is that of reacting gases, and catalyst is also in gas phase, and that is the lead chamber process for sulfuric acid, in which sulfur dioxide is treated with oxygen reversibly oxidized to sulfur trioxide. The catalysts are oxides of nitrogen, NO and NO2. Allah Hafiz.